Okay, first of all, we got y equals 1/2 x plus 3, so we say, well, okay, y equals f of x equals 1/2 x plus 3. Okay, because we said originally this is a linear function, y equals f of x. We want to use that notation. And then we want to verify that f of 2 does equal 4 for this function, or this function. Okay, because that was our condition, f of 2 equals 4. Well, if we plug in 2 for x, we get 1/2 times 2 added to 3, and that would be our y value. And of course, 1/2 of 2 is 1. We add 1 to 3, we get 4. So we can see very quickly that f of 2 does equal 4. We just plug 2 in, we get 4. So this verifies that we've satisfied this condition. And by setting our expression for slope equal to 1/2, we're guaranteed that if we did the algebra correctly, this thing will have a slope of 1/2. Now, what's the x-intercept of this function? Well, what's the x-intercept? The x-intercept of a graph is the point at which the graph crosses the x-axis. Now, sometimes it crosses more than one point, so it's a point where the graph crosses the x-axis. If the function is linear, that means its graph is a straight line. It can cross the x-axis at most one point. Now, if it's a horizontal straight line, above or below the x-axis, it's never going to cross the x-axis. But if it's got any non-zero slope, it has to cross the x-axis somewhere. This one has a non-zero slope, so we're guaranteed that it crosses the x-axis. How do we find the point where we cross the x-axis? How do we find the x-intercept? Well, we have to observe that if the graph crosses the x-axis, it does it at a point where y equals 0, because that's what characterizes the x-axis. Okay, so the x-intercept occurs when y equals 0. So how do we determine the x-intercept? Well, we let y equal 0, and we solve for x. So we just plug in y equals 0 and solve for x. Now our equation becomes 0 equals 1/2 x plus 3. Obviously, if y is 0, that's what we get. And people like to see the x on the left-hand side, so yeah, we can switch the sides. So we switch the sides, we get 1/2 x plus 3 equals 0. Then what do? We subtract 3 from both sides. We get our 1/2 x plus 3 here, and then we do a minus 3, and we get our 0, and we get a minus 3. Okay? So we subtract 3 from both sides. It looks like this. And what? 3 minus 3 is 0. So we have 1/2 x plus 0, and 0 minus 3 is negative 3, so that 1/2 x plus 0 equals negative 3. Now, of course, 1/2 x plus 0 is just 1/2 x. So we have 1/2 x equals negative 3. How do we solve this? Well, one person said, well, divide both sides by 1/2. And that's perfectly valid. That's perfectly okay. But if you divide by 1/2, you're going to end up multiplying by the reciprocal of 1/2, because that's what division by fraction means. So why don't we just multiply by the reciprocal to start with? Okay, we have 1/2 x, we're going to multiply by 2 over 1, which is just like multiplying by 2, but since we've got a fraction, I wrote it 2 over 1. And then I did the same thing on the right-hand side. Well, 2 over 1 times 1/2 gives us 2 over 2, which is 1. So we have 1x, which is just x. On the right-hand side, 2 over 1 times negative 3, well, that's just like 2 times negative 3. It gives us negative 6. So we calculate x equals negative 6, and that's our x-intercept. Now, when I sketched the thing, the sketch looked like this. I didn't have these marks here, but now that I know that the intercept is at negative 6, I can put 5 marks in here, and it looks just about right with the marks that I made here. So that it's very plausible that the x-intercept is negative 6, 0. Okay, y is 0, so we have second coordinate 0. If it's on the x-axis, the second coordinate has to be 0. And if that's the case, x has to be negative 6 because of our equation here and our solution. Then we calculate the y-intercept. Now, if you know that the general form, the slope-intercept form is y equals mx plus b, you can just read the y-intercept off of that equation. You can't read the x-intercept. You have to do this. but you can read off the y-intercept, okay? But we don't want to do something here that works just for linear functions, okay? We want to see that there's a general procedure for finding an x-intercept and a y-intercept that works for any function, whether it's linear or not. So the procedure is, to find the x-intercept, you let y equal 0. And then you observe that the y-intercept occurs on the y-axis, and on the y-axis, x is 0. So the y-intercept occurs when x is 0. We have to lock that idea in. So, well, it turns out that for most functions, it's pretty easy to find the y-intercept, because all you do is you plug in 0 for x. Here we get y equals 1/2 x plus 3 is 1/2 0 plus 3. 1/2 is 0, 0, so y equals 3. It's often very easy to find the y-intercept. It's often somewhat more difficult, slightly more difficult here, even more difficult if you've got quadratic functions or various polynomial functions, exponential functions, and so forth. But the same thing applies no matter what kind of function you have. And since we're going to be dealing with all these other types of functions in relatively short order, we want to be sure that we understand that the x-intercept occurs when y equals 0. So we take whatever our function is, replace y with 0, and solve for x. To find our y-intercept, we plug in x equals 0 into our function, and we get our y-intercept. And that turns out in this case to be 3. It's very easy to see why. And that's consistent with our picture. Somehow I lucked out and drew a pretty decent picture of this graph. Because none of the scales were on there, and when I drew the line, I just tried to make that about half of that. I came out with something that's more accurate than it deserves to be. It's just luck of the draw. Okay, so this is everything that we can conclude from the fact that we want a linear function, from the task of getting a linear function y equals f of x with f of 2 equal 4, rate of change 1/2.